AP Chemistry, Unit 2.6, Resonance and Formal Charge. So there are some serious limitations with the Lewis model. They tend to present a very black and white version of a molecule, whereas in reality we deal with shades of gray. So an example would be ozone. So ozone would have one single and one double bond whenever we draw out the Lewis structure. But in reality, that's not really how the ozone molecule actually presents itself. Instead, we have two identical in-between bonds that are shorter than a single bond but longer than a double bond. So instead of it looking something like this, where we kind of go back and forth between these two options for Lewis structures, instead we kind of have this situation where we have like a 1.5 bond for each of these auxiliary oxygens, and we have a total charge for the auxiliary oxygen is like -0.5 instead of a full -1 charge. The central still has a +1 charge though. And this is what is known as resonance. So resonance is where we are going in between multiple different options for where the double and single bonds could possibly be. And there's no real good reason for the right oxygen to be the single bonded oxygen versus the left oxygen to be the single bonded oxygen. And so they resonate between these two Lewis structures, and so we end up with this kind of like half thing. And that's what resonance is when we are going back and forth between multiple valid Lewis options. One of the ways that we can determine a good Lewis structure is by looking at formal charges. Formal charges help to establish the location of any quote-unquote extra electrons and can be added together to get the full charge for the full compound. It's pretty easy to find the formal charge for any particular atom. To check the formal charge for each atom, you would just go ahead and look at how many electrons they have full ownership of versus how many valence electrons they normally have. So how many do they have in that particular molecule versus how many do they start off with. So if we're looking between this carbon monoxide and the ozone again, the carbon monoxide, carbon normally has 4 valence electrons. However, in this structure, it has access to 5. And I've denoted that by circling the electrons that it would quote unquote have full ownership of in this like peachy color. So I have just the electrons that are closest to carbon are the ones that carbon quote unquote has full ownership of. And it has 5 instead of the 4 that it normally would. So that means that this carbon has 1 extra electron than it should have, and therefore its formal charge would be -1. Oxygen normally has 6 valence electrons. However, in this particular structure, it only has access to 5, as denoted by the circles in red. And so therefore it has access to 1 less electron than it normally would, so it would have a formal charge of +1. My left oxygen for my ozone, I should have 6, but I have access to 7, so my formal charge is -1. My middle oxygen, I have, normally I have access to 6, but right now I only have access to 5, so my formal charge is +1. And then my right oxygen, I should have access to 6, and I do have access to 6, so my formal charge is going to be 0. So again, my formal charges are just going to be the differentials between how many valence electrons I should have based off of the periodic table versus how many I actually have in the actual Lewis model. And when they are added together, it should equal the total charge for the molecule. So carbon monoxide has a net charge of 0, and so when I add -1 and +1, it equals 0, which is the total charge. So that means that my formal charges look good. And then same thing for ozone. I have a total net charge of 0, and when I add -1, +1, and 0, I end up with a total net charge of 0. So that means that that looks good as well. Important thing, again, the way that we utilize formal charges to kind of denote if a specific Lewis structure is valid, we want to minimize the formal charges. So we want to minimize how many atoms have formal charges at all. And then we also want to minimize the overall size of those formal charges. So we want as small of a number for the formal charges as possible as well.